In this example, we'll demonstrate two pieces of functionality in Factry Historian. On the one hand, we'll demonstrate asset prototyping, where we can build a template or a prototype of an asset and instantiate it multiple times. On the other hand, we'll also be demonstrating the new Steam functions that come in Factry Historian. To do that, we'll use this simple example where we have a heat exchanger that heats water coming in at a certain temperature, at a certain flow rate, and heats the water to a certain output temperature. And in this example, we'll want to know what is the output temperature of the water, so the value here. To do that, we'll use steam, saturated steam with a certain temperature, and of course then also a certain pressure with a certain mass flow rate as well. So steam will be the source of heat in this case, and the question will thus be how much heat is exchanged in the heat exchanger from the steam to the water, and as a question, thus what is the outlet temperature of the water throughout or coming out of the heat exchanger. To demonstrate that functionality, we'll go to Factry Historian and click on Events and go and take a look at our prototype. For this demo, I already created my prototype and I'll take you through the different steps here. So I created a heat exchanger prototype and attached a couple of properties to that. When looking at our example here, we'll probably need input measurements coming from tags in Historian. We'll have inlet for the steam, we'll have the temperature and pressure. Just the pressure, for example, will do, as we know that we're dealing with saturated steam here. And of course, we need a mass flow rate for the steam. The water being heated in the heat exchanger also has an inlet temperature and a mass flow rate. Of course, the mass flow rate on the outlet side will be the same. And for this demo, we are interested in the outlet temperature. So, going to our Historian, we see that we have an input measurement called inlet pressure. We could as well just have an inlet temperature as a tag as well on the inlet side. And for the steam, we also have a mass flow rate. With those two or three input measurements, we can create the heat or calculate the heat exchanged over the heat exchanger. So for that, we added an additional property called hex, which is a calculation that will run every 10 seconds and will have the name sim_hex_ and then the name of our asset. We'll make sure that the calculation runs every 10 seconds, and we need two inputs, the mass flow rate and the inlet pressure. Using the Steam functions library in the scripting language in Factry Historian, we then calculate the saturated vapor specific enthalpy and the saturated liquid specific enthalpy. The difference between both is just the energy coming out of condensation, and then we multiply that with our mass flow rate. The end result will give us the heat exchanged over the heat exchanger measured in kilowatts or kilojoules per second. Okay, so now we have our heat exchanged. Next, we need to we can use that value to calculate how much the temperature will increase from our process fluid. So our process fluid will have an inlet temperature, a mass flow rate, and of course also a specific heat capacity in the case of water that is known, of course. And we're interested in the process fluid outlet temperature. Our calculation will also run every 10 seconds, and the inputs needed for that are the heat exchanged over the heat exchanger, or process fluid inlet temperature, mass flow rate, and specific heat capacity. We use the following calculation to calculate the results, and as an engineering spec, we'll know that the outlet temperature is expressed in degrees centigrades. You might have noticed that several of these values, for example, the inlet pressure has a measurement name called sim_inlet pressure and then an asset metadata number. Same with temperature and mass flow rate, for example. When instantiating the prototype, we'll assign a number to our heat exchanger, for example, number 1, which will ultimately link the prototype to the correct measurement names in our historian. And in the case of calculations, create measurements or create calculations with appropriate naming. So let's make this more concrete. Our specific example uses saturated steam with a pressure of 9 bars at a flow rate of 0.31 kilograms per second, condensing in the heat exchanger. It is heating water with an inlet temperature of 10 degrees centigrade at a mass flow rate of 3 kilograms per second. And in this example, we're interested in the outlet temperature. So in Factry Historian, in real life, you would have tags with your steam pressure, steam temperature, inlet water temperature, and so on. In this case, these are simulated values. So the inlet pressure of 9 bars, for example, the inlet temperature of 175 degrees centigrade, or in this example, in Kelvin, a mass flow rate of 0.31 kilograms per second, a specific heat capacity of water, and so on. So we have the input measurements available, and now we're going to instantiate our prototype based on so we're going to instantiate our prototype. To do that, we'll go to the asset structure and create an asset from a prototype, select our heat exchanger, and then we enter the wizard to create an asset from the prototype. On the left, you see green check marks and red crosses. The green check marks mean that there is a calculation or measurement ready to be created when instantiating it, and the red crosses mean that there are input measurements that are not automatically found or linked to the heat exchanger yet. We'll do that using metadata, in this case the number. But first we'll give our heat exchanger a name, heat exchanger 1, and the number is 1. We see that as soon as we enter the number 1, that all or most of these values have turned into green check marks. Historian has found sim inlet pressure 1 based on the number 1. It has found the mass flow rate, it has found the inlet temperature, but it apparently has not found the fluid specific heat capacity yet. So let's do that manually. Click here. We have now ultimately found our value, and we see that the asset is now green. We can submit it. And from this point on, we have now created a heat exchanger asset based on the prototype, and all attached measurements and calculations are now running in the background. So what does that look like for our calculations? Going back to the calculations tab, we already saw our inlet pressure, inlet temperature, and so on. But now we see that new calculations have been created. For example, the heat exchanged over the heat exchanger is being calculated as this value here with input and output measurements available. We see the heat capacity that was known, and ultimately we were interested in the fluid outlet temperature. In our table, we see that it seems to have calculated 60 degrees centigrade. So let's take a look at that value in Grafana now. So for that, we'll be going to our dashboard, clicking Add Visualization, and using the Factry Historian data source. We have our heat exchanger here. We already knew the inlet temperature of our process fluid, which was 10 degrees centigrade. And now we have calculations running for the outlet temperature as well. And as you can see, our inlet temperature is 10 degrees centigrade, and our outlet temperature is now at 60.1 degrees centigrade. So with this simple example, going back to our drawing here, we have calculated using steam functions how much energy is being exchanged in the heat exchanger, and using that value with a flow rate of 3 kilograms per second and 10 degrees centigrade of input temperature, we have calculated that the water is being heated to a value of 60.1 degrees centigrade. This concludes our example where we've used prototypes, Steam functions, and the Grafana data source plugin to make this simple example a reality.